this work is about text mining. We try to find how to get insight of potential cyber threat. So this research proposed an automatic threat action retrieval system. Threat action is the attacker's action, how to attack our system. So we try to collect various data sources like instant and darknet as foreign, and try to extract those important information from those articles. The outline of the presentation is as follows. That the first part, we're gonna introduce the research and how important it is, and the second part is do some of the literature review and talking about some of the related past research. The third part is the methodology, explain how we did it, and the fourth part is system evaluation plus the performance comparison with the past work, and the last is draw the conclusion. Organization and business apply modern information technology to expand services and try to improve work efficiency. But in the meantime, they are facing potential cyber attacks because the more they gain more profit, likewise, attackers gonna use the IT technology to attack us. For current situation, the advance of IT and the hacking technique, so it will increasing number of attacks, and the attack gonna be more sophistication than before. And hackers becomes organized group, so they are not doing random work like before. They customize malware and attack target and profitable organizations. And in the meantime, because of the globalization, some of the APT group were sponsored by government, and some of the reasons information welfare and data stealing. So it would like we have a lot of APT threats for all the company and the governments. So we try to find a solution to improve information security and try to reduce the number of cyber attack risk. PPT is a short name for tactics, techniques, and procedures. And TTP are patterns of activities and methods associated with a specific threat actor or a group, attacker group. If we can identify TTP, which means that it will help us to identify common attack factors and possible vulnerable system that likely be compromised. If we know TTP, we can try to prevent those information security risk. The key element for TTP is threat actions. That is why it motivates our research to try to finding those threat actions from the articles that I mentioned. Cyber threat intelligence, short name for CTI. The definition is CTI is like evidence-based knowledge about the attackers. We can know their motivation, intent, and capability, and how they enable environment, and how they operate their actions. So the CTI will focus on some of the attack events or series of events or the attack trends. If we have a CTI, which means that we know some of the threat intelligence that probably some company already been attacked, we have those information, we can try to prevent our vulnerable system and prevent some of the scheme, deploy some of the prevention scheme in advance so that we won't be compromised or breached. So our motivation is most people and most traditional defense is using the IDS, intrusion detection system, and firewalls, try to use rule-based defense mechanism and use the trigger if alerts was triggered, which means that we were attacked. But because the APT group, they will use a customized attack and try to avoid and invade those defense mechanism, it will attack us. So we try to use a proactive defense, which means that if we know TTP, their tactic and procedure, we can deploy the defense mechanism in advance. So the best way to defense APT attack is proactive defense. There are several types of CTI, like structured CTI, semi-structured, and unstructured. For the amount of CTI, most CTI is unstructured, and it's hard to comprehend using the machine. And the type of CTI like structured, like the hash values, which means the malware we can hash, and we can use this to detect if there's malware or not, or IP address like a blacklist. Some of the control center, if we know those are blacklist, we can set rule, prevent our client to connect those blacklist. And all the domain name or URL, those are structured. And the thing is, we try to extract valuable information from unstructured information, which is more tough than extract from structured information. But most CTI research focus on extract structured CTI, which means indicator of compromise, like malware hash, phishing domain, or blacklist. For document classification, it's much harder. Most research will rely on human intelligence before they can extract valuable information. But human intelligence is labor-intensive work, so we try to extract CTI using a more automatic way. To try to retrieve threat action automatically, which means that we try to replace human intelligence with automatic approach, which we apply information retrieval technology, neural network, and the word embedding technique to achieve the above goal. The below is the example, like we try to extract those valuable information, like the one hiding malware, malicious operation, avoid raising suspicions. Those are the threat action that we try to extract, so that we know how they attack us and how we can prevent those in advance. The related work is about text mining. We will apply those techniques, like TF, IDF, an article. We can extract keywords about this article. And to apply machine learning, we need to encode those keywords. The keywords embedding a model we use is following the word to vect, dark to vect, and fast text. For matching the keywords similarity, we use BM25. BM represent as a best match. TF-IDF, shorthand for term frequency, inverse document frequency. So it's a numerical statistic to reflect the importance of a word in the document. The formula is listed below. It will compare the frequency in this document as well as in the whole corpus. For word representation, we use the following three word embedding models. The first one, word to vect, use a neural network model to learn word association. So they represent each distinct word with a list of numbers, which are called vector. So these three models represent keywords, features, which sometimes we will call words, into a vector space. But the first model lose the ordering of the words. It's kind of ignore semantics of the words. So improvement model is dark to vect, represent a document by a vect. It can overcome the weakness of the first model. Fast text, from the meaning of fast text, it's improve the performance and apply n-gram to build up text representation. It improves the first model as well. BM25 means best matching. It scores each document according to the document's relevance to the particular text query. So compared to TF-IDF, it measures relative concentration. But BM25 cast the relevance as a probability problem. So it improves TF-IDF. We want to apply different model to see which one is the best for our proposed research method. So that's why we study those different model and will apply to our research. Threat tactics, sometimes we'll call threat action, is composed a set of attack action. Attack action, likewise, it will compose like at least two words, like a verb plus noun, or like this, like a take, screenshot, remote control. It consists of a phrase, two words instead of one word. So common formula is like a verb plus noun. So threat attack action, which means that we can extract TTI, the first T, attack tactics. The past research on threat action extraction is as follows, like TTP, drill, action minor, and feature smith. And we will compare these two, the first two past research with ours. And from the method, the TTP drill, it applied BM25, but they build an ontology defined by expert, and this is human intelligence, and it requires intensive labor work. This is why we try to improve if we can not building ontology. It will save a lot of time. And like action minor, similarly, they build up and then extract, but they have to compile this similarity. So the method for these three research, they build ontology and then extract candidate threat action and then compare which one is the key threat action by comparing the similarity with some predefined terms. So in summary, past research used the following step. They manually built ontology and then extract candidate threat action list and extract for all the phrases with the following pattern: verb, adjective, and plus noun, and compare the candidate threat action list with the terms built from ontology. So in summary, we can see they have this step like candidate threat action, but they pre-built the ontology, and by the similarity comparison, they can extract threat action. The proposed solution is try to improve by automation. For ontology, we try to build key attack action list to replace the human intelligence built ontology. And for the similarity calculation, we apply a machine learning model to do the comparison. And likewise, we try to extract threat actions. So the methodology can be listed into the following 6 steps: data collection, data cleaning, and extract candidate threat action. And above that, we need to extract key threat action, because those candidate threat action might not be security relevance. So we try to build a list of action verb to compare so that we can extract key threat actions. And through the similarity algorithm, we can extract threat action from an article. The first step is data collection. We have multiple sources: APT, notes, news, forums. So we use web crawler to extract that. And for the APT notes, it's a PDF format. So we use the following tool to extract their text. For news, it is extract from web pages. And likewise, we have parser to extract the text form. The second component is data cleaning. The purpose of the data cleaning is try to reduce feature dimension. So we use tokenization and stop word list to remove common words and use lemmatization stemming to reduce the complexity. The third component is candidate thread action extraction. We have post stacking and CFG to extract candidate thread actions. Post stacking can tag terms into verb, noun, adjective, verb, and etc. To use CFG to extract short phrases based on the following rule: noun and verb, verb plus noun. So using the above rule, sometimes we might extract non-security relevant phrases like read book, write words, which will be included in our candidate thread extraction. So that is why we have to have an extra step, key thread action extraction, to fill out those unrelated non-security phrases. For key thread action extraction, we have the following step. We use WordNet and MITRE ATT&CK, terms from MITRE ATT&CK and from the AP CAPEC, which is a list of security related terms to build up our key thread action extraction module. Use this, we can compare and extract thread action from a document. So this part, the key thread action extraction, have two problems to solve: how to determine effective thread action and how to fill the thread actions. For past work, they use thread action defined by expert. So those terms can be extracted from MITRE ATT&CK and CAPEC. And using the above word list, we can extract key thread actions. For similarity, we use the following embedding algorithms. I guess my time is up. I will try to use a similarity comparison to compare and extract the meaningful thread action list from a document. Our system evaluation consists of two experiments. One is system validation to make sure we extract the efficient thread action, and the second part is performance comparison. And we have those data sources that I mentioned before. And for the system validation, we use a different filtering model and matching method. The best one is PF, IDF plus WordNet. And the matching similarity comparison, we combine the four model to get the best solution. And performance comparison, we compare with the past two research, and our performance is better than theirs. So the conclusion is it is possible to automatically extract key thread actions without the human intelligence. And the two-stage filtering can extract key thread actions. So, and if we apply hybrid similarity algorithms, we can improve the detection rate. It's conclude my presentation.